Hey students, welcome back. This is going to be a real quick short video because the lab we do actually helps illustrate it a lot better, but I also like to get this video in so we kind of have an idea before we do the lab, or maybe even after, kind of depending on where we're at. So this is energy of phase changes, and so this is maybe something you saw in your last chem class and maybe not, so we'll kind of make sure we'll assume no one has seen it and we'll play it that way. So you're still going to use Q equals MC delta T, but what we're going to have is what is called a heating curve. So right here is a picture of a heating curve. So this shows phase changes of a substance. And what we have right here, this is a phase change or a heating curve of water. And so as you can see, like as heat is absorbed, we go through the three different states. We don't actually talk about plasma here. But what we have is like, so from negative 40 to 0, that's the solid phase of water. So we're in the solid phase, and this is all solid and it's water. Then once we hit 0 degrees, the water starts to melt. And it actually will stay at 0 degrees until it is past the equilibrium. We'll talk a little bit more about that, but it will stay at 0 degrees. So it kind of levels out at 0 degrees for a while. And then it's all liquid. And then we add heat. And once we get up to 100 degrees Celsius, then we're at boiling. And once we get mainly to the gas phase, then we have the temperature go back up. So note, a couple of things that we want to note is that these temperatures stay the same until we kind of are exiting that phase change, if you will. Now, the other thing I want us to kind of take a peek of is this one from here to here is not very big compared to here to here. I would like to know, why is that? Why do you suppose that it takes very little energy, if you will, because we have to keep adding energy for this to happen, from a solid to a liquid versus a liquid to a gas? And this is true for all substances, not just water. So take a second, come up with an idea. All right. And here's what we've got. Here's what is happening. When we change from a solid to a liquid, we're only breaking a few intermolecular forces. Breaking just a few, right? Breaking a few IMFs. Okay? Not very many, right? Because we still have some intermolecular forces, we still have some interaction there. But when we boil, when we change from a liquid to a gas, the IMFs, we have to break all the IMFs. Break all the IMFs. So everything has to be broken. So that's why that line, or it takes so much more energy, so much more energy, yeah, that's right, to change from a liquid to a gas. All right. Again, we're going to do this, the heat of fusion of ice lab, or maybe we've already done it, but hopefully this will kind of get us there. One last thing, we can do the calculation for all the energy it takes to transfer here. I haven't seen one on an AP test, but I have seen some college professors ask it, so we might do that in class. Okay, see you next time.